Okay, so I wanted to just give you a idea of the first test, how I graded it, what the main problems were. So on your test, you see three numbers. You see total points. So the test had 200 total points. Most problems were worth 20 points. Um, the ones that were worth 10 points were 5 and 6. All the others were worth 20 points. Now, if you add up all the points that I took off, you'll get the number of points taken off. So, I might have minus 50 for total points, 200, so many off. And then I apply a curve to this. So I take a certain percentage of this number, and then I use that percentage to calculate the grade. So the final curve grade doesn't take the total amount here, it takes some percentage of it. That's basically how it works. Okay, now as far as the test is concerned, there were two versions of the test. The test that was taken, I can't remember which one it was, but the first problem was written as such, and it turns out you can't factor that thing easily. This is problem number one. So I didn't take any points off if you didn't get the zeros. Now the second, I think the second test had this as the equation, and this one you could factor easily. So this one I did grade. This one you got lucky and I didn't mark off any points for the x-intercepts. A lot of people forgot to put the answers in coordinate pairs. So say you factor this and you set it equal to 0, you would get x equals -6 as a 0, but the intercepts are coordinate pairs, and I ask you to do that in the problem. So you would put -6, 0 for this x-intercept and -1, 0 for that. So I took points off associated with that error. Completing the square. So the people who did really well on the test knew how to do completing the square. And a lot of the rest of you didn't know how to do completing the square. And I know I specifically went over that many times, and it's needed in the next chapter. So even though you might like to use just factoring by observation, that's a skill you need to do more than that. Now, you could use the quadratic equation, but the quadratic equation isn't that useful for putting in a form, chapter 2, section 1, putting it in standard form. So just using the quadratic formula would give you the zeros, but it also leaves out certain important information. So I'm just going to go through one of the two problems to show you the technique. And again, you're going to need to know how to do this for section 1 and chapter 2. So you take the coefficient here, 6, you divide by 2, always 2, and you square it. And what I'm going to do here is I'm going to put space in, so I'll have a place to put a number and subtract a number. So this is 3, 6 divided by 2 is 3, squared is 9. So you add 9. This is always a positive number because you're always squaring it. So whether this is -6 or +6, you're still going to get 9. So you always add a number here, and therefore you always subtract a number, the same number there. Now these three you can make into a complete square by taking this number, 3, and adding it, or whatever this number is. If it's negative, then put in negative. If it's positive, put in positive. And that's the way that you can rewrite these three terms as a complete square, meaning it's x plus or minus something quantity squared. Over here, you just add the two numbers together, which is -23. So that's how you would change the form of the equation. You set that equal to 0 to find the zeros. So you would add 23 to both sides of the equation. You would take the square root of both sides And when you take the square root, you get this plus or minus square root. And then you would subtract 3 from both sides to solve for x. And so that is completing the square. Okay. And moving along, as far as the graphs are concerned, I know I emphasize this over and over and over and over again. And so the fact you didn't do this, again, indicates that you're really not paying attention. So, for example, one of the forms of the test looked like this for problem number 7. And I asked you for the transformations. If you did not write it this way, because I said it over and over and over again in class, even if you stated the correct transformations, if you didn't rewrite it as this, I took points off. And I kept taking points off if you kept doing it. So you saw that a lot. I mean, a lot of the problems had this situation. So you factor out a negative sign. And so this negative x becomes positive x. This positive 2 becomes negative 2. And as a consequence, you got x minus h. So h in this case is 2, which means you have an x shift of plus 2. Now, if you looked at this and said, I have an x shift of plus 2, I don't know how you got that, because this is what I talked about in class. And the other way that you could get the shift right, is you put it into your graphing calculator and plot the function and get the right answer. But the only way I know that you are not doing that is by writing this form of the original equation. So I took points off of that, and I took it off again and again if you didn't do it. Okay. So thank you to the few people that did do that. So that's another comment. You know, some of you, I think, see pre-calculus as, oh, I did this in Algebra 2, so I don't really have to study that much because I already know how to do that. And the point is, the things that I'm teaching you here, yeah, you may have had them before, so it's a good review, but also the things you need for calculus, you know, what you've taken before is you have taken what you needed to take to pass the class, to pass the SOL or whatever. What I'm teaching you is the things you need to know when you take calculus. So you need to pay more attention to what I'm telling you. Okay. Now, if there was some inconsistency between what you said were the shifts and what you plotted, then again, I don't know whether you're confused or whether you are plotting the functions and again reading some things off the graph. So that's why you get points taken off for inconsistencies between what you said were the transformations and what you showed were the transformations. Now, as far as the composite functions, let's work that problem out. So there were 2 versions, and so I'm going to use this particular version. F of x equals x squared plus 3. G of x equals the square root of x minus 2. So the composite functions, f of g of x, you take this and you plug it in there. So instead of x squared, you get the square root of x minus 1 square root. Square root of x minus 1 squared. Now, you could simplify this as just x minus 2 plus 3, which would be x minus 1. The problem there is if you do simplify it, you've got to go back to this original form of the equation when it comes to the domain. So this is 2g of f of x. So there you plug in this into there. Now in this case, you can go ahead and simplify without affecting the domain. So if you simplify this down, so what we've done is plugged in for x, put x squared plus 3, and then 3 minus 2 is positive 1. So that's g of f of x. Now, when it comes down to the domain, this is all real numbers. So I'm going to just do it in this notation. So that's all real numbers, however you said it. Here, x has to be greater than or equal to 2, because if x is less than 2, the argument of the square root function is going to be negative. And you can't do that. So those are the domains for the two original functions. As far as the composite functions, we look at this version before it's squared. And so this has the same domain as g of x. So this would be x has to be greater than or equal to 2, because if I plug in x equals less than 2, like 0, I'll get the square root of a negative number. And I can't do that. Here, now this one you'd say I could use all real numbers, but you have to go back to the original unsimplified version of the composite function. And then over here, you can see, no matter what the sign of x is, when you square it, this will become positive. So this is always positive. A positive number plus 1 is always a positive number. So it doesn't matter what x value I use here, I'm still going to have an expression that I can evaluate. So this one has all real numbers. And again, I could have written this as 2, comma, with a square bracket, comma, positive infinity. Same down here, 2, comma, infinity, like that. Now the last problem, a fair number of you didn't write the final equation out. So it says state the parent function in its transformed version. So that means to write the equation. And you can see the shifts easily on the graph. Shift x is minus 2, because that's where the square root function starts. So it is a square root function. The parent function is the square root of x. And the y is also minus 2. You can also see that it's flipped. This is the original function. It's flipped across the y-axis. And as a consequence, when you write the function out, you would go to the square root of negative, and then you would write in the transformation that you see. So it has a shift of negative 2, so I would do x plus 2 here, and then I would subtract 2 from there for the y shift. Now you could rewrite this as negative x minus 2, and some of you did that. Again, I just don't think you have the ability to look at this directly. The best thing to do is to use this notation we talked about earlier. This reflects a y reflection. This reflects a shift of negative 2. And then if you want to write it out and go here and write that out, that's fine. But if you just left it as this, or if you took this and then simplified to that, but if you went straight to that, I took off points. So again, I know I talked about this many times in class. I didn't do it just for the heck of it. And again, the people who did really well in the test did this correctly, so they were paying attention. So I know it was in there. So just step up your game a little bit as far as taking the class seriously. Okay, that's it.